Okay, guys, we're going to be learning about the scientific method, a method that has been used for many years, and just a way to kind of, explain the unknown world. And so we're going to dive right in here. So, look at this. Part of the scientific method, sometimes you have to use good observation skills. If you're looking at this, you're like, you might be thinking, all right, I'm thinking two different species here, possibly. And then we keep going, and now you kind of make some observations and go, oh, what's happening here? And you don't have the whole picture yet, but you're kind of, yeah, something's happening here. Could be dancing, could be wrestling. And then bam. You can come up with a hypothesis here. You might come up with something like, I think this green creature ate the other one. Who knows? So we're going to be using a scientific method to try to figure out the unknown world. So there's some steps to the scientific method. And usually they're in order. And sometimes there's other steps, like, for instance, research can be part of this as well. But you make observations, come up with a question, form your hypothesis, do your experiment, collect your data on your experiment, kind of analyze your data, and then come up with a conclusion. Those are kind of the basic steps of the scientific method. So, an hypothesis. It's kind of your way of explaining your observation, explaining it. A lot of times we write it in the if, then. If I plant in this type of soil, then I think the plants are going to grow better, right? So that's kind of your hypothesis, right? It's your educated guess, but it must be testable. Okay? In your experiment, the key thing that people make mistakes is you need to be testing one variable at a time. You can't be testing, if you want to see how the best way to grow plants, you can't be testing the amount of water and the different type of soil. You have to be testing one of them. And then this part right here, pretty sometimes confusing for kids. Control variables. Sometimes we call them constants. Controlled variables are things that stay the same throughout the whole experiment. So if I'm trying to figure out what amount of water works best for my plant to grow, I need to make sure there's control variables, as in each plant, even though they're receiving different amounts of water, they need to be receiving the same amount of sunlight. They need to be in the same type of pot, the same type of soil. Everything needs to stay the same. Like, even when I water them, I can't water one plant at nighttime and one at day. I have to have it watered in the same time throughout the day. So those are my control variables. Your control group, which sometimes gets confused with this because the word control is in it. Control group is the group that you are basing everything off of. So my example of the amount of different amounts of water in a plant, the control group would be a plant that does not receive any water. So, and then you compare everything to that. And then next we're going to talk about independent variables and dependent variables. So the factor that is changed, or what we are manipulating, is called the independent variable. This is what you are testing. So in my plant example with water, my independent variable would be the amount of water. That is what is changing throughout the experiment. Your dependent variable is what you are measuring, what you are observing. So in my plant example, it would be how much the plant grows. I am measuring if I added 2 liters of water on this plant and it grew, 6 inches, and 3 liters grew 10 inches, my dependent variable is the 6 and 10 inches, how much it grew. Okay, the dependent variable depends on the independent variable. So let's look at a couple of these. Different fertilizers on plant growth. Well, my independent variable on that one would be the different types of fertilizers. Right here. My dependent variable would be plant growth. How much the plant grows. Okay. Let's go down to which laundry detergent works best. So in that example, the different type of laundry detergent would be my independent variable. And my dependent variable would be which one works best, based off of how clean it is, how much of the stains it gets out. So hopefully that helps you out. All right, look at this. How to get a date for Friday night. This is my question. Now, I've done a lot of experiments, I've come up with a lot of hypotheses, and I figured it out. It's tube socks. Who knew? Tube socks, right? So my hypothesis, if you wear tube socks, you will have dates for Friday night. So in this experiment, your control variables have to stay the same. So if you're asking a guy or a girl out while you're wearing your independent variable, which is the tube socks, you need to make sure you're wearing the same clothes, you're asking the same way, and then see what results are. Your dependent variable in this would be obviously how many dates you get for Friday night. So you could use a scientific method for anything. Like even my son, he loves to play Fortnite. He would probably come up with ways, what's the best way, to win a game, right? He says if he, so if you come up with a hypothesis, I can't even do it because I don't even play Fortnite. But you get the point here. You can do so many things with the scientific method. It's an awesome way to figure out the unknown world. Okay, so quick review here on the scientific method. So you ask a question. You do some research on that question, right? You have your observations. Once you have that, then you come up with your hypothesis. Based off everything I saw, I think if we use this fertilizer, I believe my plant's going to grow the best. So you have that. Okay, so you do your test. You test out your different fertilizers. Make sure you have your control one. The control one would be a plant without fertilizer, right? And then you draw your conclusion, and you say, is it true? If it's true, report. If it's false, you still report, right? But if it's false, think again and do it all over again. And that is the scientific method. For scientific method to become a theory, it just basically, it needs to be supported by lots and lots of evidence. So the theory of evolution first started out as a scientific method, as just a hypothesis, and over time people have used it, the hypothesis, and it has become more of a fact, and therefore we now call it the theory of evolution. So hopefully that helps you guys. That's the basics of scientific method. All right, see you later.